Hello, this is a small demonstration of how to use logic gates with C++ programming. Um, I learned C++ by watching videos from a person who has a site on YouTube called Brocode. He's really good at what he does. But one thing he doesn't show you is how to use logic gates in this kind of manner. I'm using this to simulate my digital designs because first I was doing it in LabVIEW, and you can run it and then you can simulate it and make sure it's going to work. If it's going to work in LabVIEW, I know it's going to work on a board as long as I connect it correctly on a board. So I'm going to do it in C++ because LabVIEW costs $500. I can't afford that software. So C++ I can do for free. I mean, this is just a little text file. I have a free compiler. I compile it and I run the code and it works. This code, you can use it and it works. This is for the test gates. This is a function I call test gates. I say and it does the and function. I type test gates or, and it does the or function. And nor, it does those functions. And I do the same thing with multi-input gates. Now, the multi-input gates has it's four inputs and one output. Then I have a decoder and an encoder that I have in here as well. And again, it's to if I design something on here and I want to put it on I can simulate to make sure that the truth table works. And I can show you that right here. Like an AND gate, this is the actual truth table of an AND gate. This is what this software performs. Same with the OR gate, NAND gate, NOR gate. Same with the multi-input AND gate, OR gate, NAND gate, NOR gates. You can see the truth table is correct. The thing is, the software is running. It's simulating what an AND gate, NOR gate does. It's simulating this. So here's my 3 input, 5 output decoder. It works. This is exactly what I have on that board that I've designed. So this is nothing selected. It's 3 inputs. It's all zeros, nothing selected. Here's 1, so output 1, output 2, output 3, output 4, and after that, I have a circuitry inside that circuit that makes it go to none state again for the rest of these. And then I have my encoder, which, this is logic. It's active low, meaning a low is going to give me a high on the output. That's the active. What I should say is, because I have a NAND gate on the output, I'm inverting it. That's making an active high on the output. It's active low on the input. So the low, this is the signal that I'm using. This is what I'm looking for, is a low. And it turns into a high on the output. So that would be 1, 2, 3, and then 4. And it's encoding it into binary. So that works, and I can show you that's working. That's actually this program right here. And I'll scroll through this slowly so you can copy it if you want to. I'll even make it larger so you can see it. That way you can copy it if you want to. That is line 51. So now I'm down to line 96. 96. Now I'm down to line 141. Just down here. Now I'm down to line 181. That's at 181. Now I'm down to line 228. It's right here. And that's the end of the code right there. That's the end of it. So 251. So you can type that in, copy it yourself. I'll compile it and I'm going to show you that it works. So I'll lower that down like this. I'm using MinGW as my compiler, and this is my command to compile it. G++ space test2.cpp, because that is my name of my file, dash lowercase o. Then I do test2, and that's going to create an exe right here called test2. I'll just do this as test. I'll say test4 so you can see it'll create a new executable file. And there's a new executable file. It just came up over here. To call it, I would say test4. Because if you look, I'm on the desktop. This is my path. I'm on the desktop. So I'll type test4, and it will run my code. And you can see it works, and the truth table works. So that's a way to do logical design and simulate your designs in C++. I hope you have a good day.